Okay, for part A, when you see the slope field phrase, that means we're going to be making some hash marks here. So they give us that derivative. Remember, derivative is slope, right? So you don't have to write down the points there, but sometimes it'll help me on these problems to write down the 12 points and make sure I get them all, make sure I'm real careful with the arithmetic because we don't get a calculator on this problem. And all you're simply going to do is take those coordinates, the x and y, and plug those in for x and y into your derivative. That'll give you your slope right there, okay? So I wrote these four at the top here. When I plug those in, notice that x was 0. You had 0 divided by a number on the top, 0 on the top. So that means the slope for all those are going to be 0. So at each one of those dots, I made a horizontal hash mark. And then all the other points, again, I'm just taking, like, if I take this point here, I'm just taking that x equals 1, plugging it in for that x right there. And I'm going to take that y equals 2, plug it in for that y right there. And that's going to give us a -2 over a +2, which is a -1 for that slope. Now, when you are making your hash marks, all you have to do, it's all relative. And so if you have a slope of 1, you'll make that positive. A slope of -1, you'll make that negative. And if a slope is 2, you just got to make that steeper than the slope of 1. So they should be able to tell just by looking at it what those slopes, what those directions are going to be. So notice that this point here had a slope of -2, so that was a little bit steeper. This point here had a slope of -1, so that was less steep. All right, and then this one here had a slope of 2, so that was a steeper hash mark, and this had a slope of 1, so that was the less steep hash mark right there. And then just make sure it tells you you have 12 of them. So just make sure you got all 12, and then that's all you need for part A when it says about the slope field. Sometimes it'll have us trace the curve, but that'll be on a different problem. When we move to letter B, the key phrase here is it says write an equation for the tangent line. And so when you see write the equation of the tangent line, that's when you're going to need a point and a slope. So they give us the point, and then to get the slope, that's what we calculated up there. At that point, 1, -1, where to go? At the point 1, -1, that's going to be right here where that slope is equal to 2. Now, if you didn't calculate that yet, you would then take those points and you would plug that into the derivative to get that our slope is going to be equal to the 2, right? And so once you have your point and your slope, you do your point slope form. There's the equation of the tangent line. They will accept that point slope form as the equation of the tangent line, but notice it also asks us to approximate alpha of 1.1. So you're going to use that tangent line. So anytime I use it for something, I like to go ahead and just get that y by itself. So I solved it for the y, and this is the tangent line. And then if you're going to use it to approximate 1.1, you simply take the 1.1, plugged it in for the x right there. No calculator. I think you can handle that without the calculator there. That's going to be this -0.8 number. And remember what's going on there. Like if you have some sort of curve and then you have a tangent line, remember the point on the tangent line you're finding is about right there, and the point on the curve is going to be somewhere nearby, you know, if you're around that point, that x equals 1 number right there. In the future, they'll ask us, is this an under or over estimate? And it depends on whether that graph is concave up or concave down, because if I have a graph that's concave up, then that's going to be below the actual curve, that tangent line right there. But we'll see that on a future problem. And then letter C is going to be a very good strength of ours. We're going to practice these so much. You have done a lot harder integrals throughout the year. But when you see the phrase, find the particular solution to the differential equation, given this initial condition, when you want to find the particular solution and it says y equals, you need to go from the derivative to the original function. This is when we're going to integrate both sides, remember the plus c, and then use that point that they give us to plug it in to figure out what that c value is, right? So the first thing you got to do is multiply both sides by the dx, and then you need to separate your variables. So do legal algebra, multiply both sides by the y, get the y's with the dy, x's with the dx, and then once you separate your variables like that, then you integrate both sides. We always put the plus c on the side the x's are on. And I would like for you to get into the habit of stopping right there after you integrate, take that point that they give us, plug the 1 in for the x, plug the -1 in for the y, and plug in that point right there, and use that point to figure out what that c value is. That's your constant of integration, because that's going to be worth, you know, if you could integrate both sides, remember that c value, and get that correctly, you'll have like 5 out of the 6 points typically right there. And then the solving part is just the 1 point. at the end right there. So I always integrate both sides, remember my plus c, plug in my point right away, get that c value, and then you're supposed to, the directions do say get y equals f of x. And so you are gonna solve this thing for y. So I multiply by the 2, square root of both sides. Now this is real easy at the very end. Just be careful with this. Whenever you square root both sides, you're technically supposed to remember a plus or minus, and you need to make a choice whether you're going to choose the positive value or the negative value. And it's really, really simple how to make that choice. You always look at the initial condition, right? You have this point, 1 comma negative 1. That's your initial condition. You did y equals, you're going to do y equals plus or minus the square root. You're trying to figure out what the y is equal to, a positive or negative. And so since that y value is negative, that's why we choose the negative right there. And then we're done. Cherry.